So if we consider three objects, A, B, and C, how many rearrangement, list all the possible arrangements. So you got A, B, C, A, C, B on page 14. And then you go BAC, BCA, and CAB, CBA, right? And all together we see there are 6 ways, and which is same as writing 3 factorial. Okay, all right, good. Continue. All right, so which is 6 ways, 3 factorial. But if you put it in a circle, if you do the same arrangement like this, A, B, C, like A, B, C in clockwise, and then A, C, B, and then B, A, C, and B, C, A, and C, A, B, and C, B, A in a circle, we see there's some problem because you will find that ABC, if I search for it, it will look like this. ABC clockwise. Which one does it look like? Yeah, ABC, this one. They're the same, right? You just turn the table around. So you get repetition. So when you arrange in a circle, the best thing is to fix one object first. So in that case, there's not that many ways. So if we examine what these 2 cases, these 2 are the same, so we can't have that. I think that's the same as well. In fact, these 3 are the same. And what else are different? And then we got A, B, C, which is this, which is different. But this is same as that, isn't it? They're the same. These 2 are the same, and I think these 2 are the same. So there's only 2 ways. And the reason why there are 2 ways is if you fix one object first, if you fix A, B could go here or here, B, C, or you could have, if you fix that person, or you can do CB. So therefore, there's only 2 factorial ways. Okay, you fix one object. So that's what you do when you arrange in a circle. So let's look at another question. It says, father, mother, 6 children stand in a ring. How many arrangements are possible? So what you could do is to fix the father first. The father does not move. So there's only 7 people left. So the number of ways is just 7 factorial. Okay? Which you get the same answer. Okay. What else are there? And then we have some restrictions. Father and mother are not to stand together. So again, I will fix the father again. I'll fix the father, and then we just need to make available 7 positions. 1, 2, 3, 4, 5, 6, 7. We need to make sure that the mother can't go here. The children can go next to the father. So the mother could have 1, 2, 3, 4, 5 choices for the mother. Okay? And the children, after the mother sat down, the children can go to any of the, how many spaces left? So you've got 1, 2, 3, 4, 5, 6, 7. 7 spaces, but 1 space was taken out, so there's only 6 spaces left. So you go 6 factorial, which is arranging the children. And you should get this answer. So we'll just double check that. So 5 times 6 factorial will be 5 times 6 factorial, you will get this answer, okay? Which is 3,600. Okay, so fix a person when you arrange in a circle. We're not going to do every question, so yeah, we may like to try 37. I think that looks interesting. Let's go to 37 about the girls and the boys not being together or together. So see if you can work out. So I give you about a minute and then we'll go through the answers. We've shown you some techniques yesterday. So, okay, have a try. Example 37. the answers? Anyone? Yep. Go. Who? Okay. Jacob. Say. Yep. Yep. Good. All right. Girls are always stand together. You want to try this one as well? Yep. Together. But who are you going to fix? The boy or the girl? So you're going to fix one person. Which one are you going to fix? B. Right. They're together. Yep. 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 All right. Did it work? Let me see. 5 factorial. May work. Okay. But I think you have to fix someone. You have to fix a boy. That's fixed. So you only got 4 boys plus one group of girls. And that contributes to 5 factorial because there's 5 objects you have to rearrange. And within the group, there's 3 factorial. So you get 720. So you're going to fix the boy. Yep. Okay, usually you fix someone without the restrictions. Okay, good. All right, who tried the last one? C. Anyone else? Someone else try C? Want to share? Jessica? Did you try? All right. Who else tried? Anyone? No one tried? So I will fix a boy first. And then put the boys down. Right? And then what did you do? And then anyone? So therefore there's 4 factorial ways to arrange the boys. And then what do I do with the girls? Where do you put them? You put them in between, right? So how many choices for the first girl? Yeah, how many choice for the first girl? 5 choices. Actually, I'll write it below. So the first girl will have 5 choices, and the second girl will have 4 choices. The last girl will have 3 choices. I think you'll get it right. Does it work off just 5p3? Let's try 5p3 times by 4 factorial. Yep, got it. Done. Okay, easy. Okay, we've done that. Then we're going to move on to the next page. Next page. Principle of inclusion, exclusion. Have a try. Go to the next page. These were not arranged in a circle. So go to the next page. Have a try. How many ways can 6 girls and 2 boys be arranged in a row if the 2 boys are together? Okay, you should be able to do this. No problem. I'll ask the student to share the answer very soon. Okay, have a try. Next page, on page 16. You should be able to do all this. Because we've done a lot of questions with things together, they're very easy to do. Alright, so Ian will miss the video. That's fine, I'll put last year's video. Okay, good. Next one, permutations with duplicated objects. So, the number arrangement with the saw, let's list them all. We know it's going to be 3 factorial, 6 ways. S, W, A, what else? A, S, W, A, W, S, and W, A, S, and W, S, A. Notice that we made some real word was and yeah. Okay, anyway. Alright. So was from saw. Okay. Alright, now what's the point I'm trying to make? What if the word C where there are duplicated objects? So we could have SEE, or if the 2 E's are different, you will still have 6 ways, isn't it? So and then you got E1, S E2 or E1 S E2 S, and then E2 SE1 and E2 E1S. Okay, so there's still 3 factorial ways, but the problem is that the 2 E's are the same. So these 2 are the same. These 2 are the same. No, these 2 are different. Sorry, I mean these 2 are the same. And then these 2 in blue pen, purple, these 2 are the same. And then you got these 2 are the same. So therefore, there's exactly same. Okay, so they're exactly not 6 ways, but 3 ways, isn't it? So there are 3 ways, and because you repeated it, and there's exactly 3 factorial divided by 2 factorial ways of rearranging the 2 same letter. So you divide by 2 factorial. So therefore, in general, we have this formula for duplicated objects. So memorize this, and we're going to do some questions. Yeah, close. Thank you. All right, let's do a question. Find the number of ways to rearrange the word banana. So how many letters are there? 1, 2, 3, 4, 5, 6. 6 factorial, but you must divide by the number of repetition, which is the 3 A's and the 2 N's. So the A and the N's, that's repeated. And that's it. So let's use a calculator. You do 6 factorial. Make sure you put it as a fraction, 3 factorial, and you must put times in between. Otherwise, it doesn't work. 60. Does it make sense? Okay, pretty easy. Try the next question. And then we'll move on. And there's some other ones, so we'll just skip this, and we'll do combination today. We may finish this booklet and then give you all the old video. All right, thank you. Have a try the next question. Have a try. It's pretty easy. Close laptop. Yep, thank you. All right, try A. Find the number of different arrangements that can be made with all the letters of the word division. Okay, I've shown you the formula. It's very easy. Okay, have a try. Give you a minute or so. All right, some people have finished. We'll go through. All right, hopefully some people have answers. Marco, you finish? Have a try. All right, let's ask Keely. So, Keely, what did you do? Part A? All right, have a try. Have a think. It's the same formula. Have a try. That should be pretty easy, okay? You got it? Okay, so you have to explain what you did. So what do you do? Yep, 8 letters, and then? Yep, any other, just I's are repeated. Good. Okay, so let's try see if that works. So 8 factorial divided by 3 factorial, and you get, yep, good. Okay, good, correct. After we get the total number of ways, we can ask some probability question. Find the probability that any such arrangement chosen at random that the word begins with the letter V. Okay, so what do? So we do the total number of ways, probability, and find how many ways begins with V. So if it begins with V, it must start with V. There's only 1 way. So how many letters left? There's 7 letters. So you go 7 factorial divided by 3 factorial, because there's 3 I's. Okay, have a try. So you should get the answer 1A. All right, who want to try the next one? Next one's a little bit harder. Part 2. Who got the next one? Have a try. So again, for how many ways that begins and ends with I. Okay, have a try. Go. So your answer will be a probability equal to 6,720, and then you find how many ways begins and ends with I. Okay. Let me know you finish, and then we'll go through. So you find how many arrangement begins and ends with I. Okay, anyone got the answer? Jacob H? Yep. What did you do? Yep. 6 factorial, because once it begins with I, ends with I, the letters here are all unique. So you do not divide by any repetition. 6 unique letters. So you just ignore these two. There's only one I here, so 6 factorial. So you get 3 over 28. Thank you. Good. Any question? We'll move on. Yep. Because there's only one I in between. So the 6 stuff that I have to arrange are all unique. I don't have to divide by any repetition. Does that make sense? Yeah. Okay. All right. Next one. I will skip this. So I'll get you to watch the video. So I will just write something there. Just watch video from last year. So any blank space we didn't do, watch video from last year, because this is just a revision. You did it all last week. Let's start with combination. Combination. What are combinations? Again, we start with a brief intro. So when we arrange 2 letters, we got AB, AC, AD, and then you can go B, A, B, C, B, D, and C, A, C, D, C, D, and finally D, A, D, B, and D, C. Okay? So clearly there are exactly 4 times 3 ways, isn't it? Or just simply 4p2. 12 ways. That's for arranging. How about selecting? In that case, selecting A and B, AC, AD, but then BA is same as AB because the order is not important, so we don't include that. BC we haven't done, and BD we haven't done. CA has been done because it's same as AC, these two. CB has been done. CD hasn't done. I think that's all because DA has been done, AD. DB same as BD. DC same as CD, right? So there are exactly 6 ways, and exactly half of it is not accepted. So in that case, all we have to do is to do 4p2 divided by the repetition, 2 factorial. And for this reason, we have this formula. And this is the formula that we've seen before, which is that when we learn binomial probability. I mean binomial theorem. Okay. All right, good. All right. Okay, good. So now we'll do some questions. Now you don't have to use this formula. You just have to be able to do this. You don't have to quote the whole formula when you do it because it's very long to quote. So let's do some questions. And we also know from binomial theorem that NCR is same as NCM minus R, the symmetrical property. For example, if I got, say, 10C0, 10C1, I'm actually not going to use 10 because, okay, let's say we've got, say, 5C0, 5C1, and then you got 5C4, 5C5, 5C4. These two are equal. 5C0 is same as 5C5. 5C1 equal to 5C4, right? This is what this symmetrical property. And the question is, why is it symmetrical? Okay, so the reason why they are symmetrical is because actually we'll do the next example explains why they are symmetrical. Okay, so 4 books are selected from 10 books. Remember the keyword select. How many selections are possible? You just have to do 10C4. So how many ways of selecting 4 different books from 10 books? So you go 10, C4, 210 ways to select 4 different books from 10 books. What if you want to select 6 books? Does it give you the same answer? In fact, it does. And the question is, why does it give you the same answer? Because once you select the 4 books, you automatically selected the 6 books, isn't it? They are the same, right? Because each time you select 4 books, you've already selected the 6 books. That's why they are matched. So now you see why they are symmetrical. Let's do the next question. 5 prefects are selected from a class of 20 students. How many selections are possible? Have a think. We're going to ask another student to do. Okay, I haven't asked a student. So Alia, can you tell me 48? Should be pretty easy. Just tell me what you're going to write. Now you should know because you're selecting 5 prefects from 20 students. Have a try. That's it, easy. All right, you don't have to think. Well done. Okay, 20C5. You just select C5. Okay, good. That answer, 15504 ways. Okay, so many ways to select 5 people from 20. Okay, good. Let's move on. What's the next question? We're going to do some harder questions. And then we're going to do some restriction questions. And then we'll just may finish there or may even do some problems as well. Okay, I may even finish. So we'll see how we go. Okay, any question? Move on. Is that easy? Okay, let's look at 49. 15 people, 10 men, 5 women. Community of 5. How many selections are possible? So who want to have a try? Tell me. 15C5, yep. So you don't have to worry about what's in the group because just say 5 people. Okay, that should be easy. Okay, next one. Now you have to be a bit more specific. 2 boys, 3 girls to be selected from 5 boys, 4 girls. What should we do? All right, maybe Mark will know. Marco, what's the answer? How would you do it? Did I have a read? Give you a couple more seconds. Okay, you're not even on the right page. All right, hurry up. How about look at the question? What would you do? How about tell me how many ways to select the girls? What would you do? Perfect. Okay, good. So we got the answer 40. Okay, yes, Mitchell. All right, okay, good. All right, next question will be easy, so won't do that. 5 boys and 3 boys. Okay, let's look at this problem. Example 52. How many ways of dividing 8 boys into 2 sets containing 5 boys and 3 boys? So when you divide into 2 sets, it's same as selecting 5 people. And automatically you get the other. When you select 5 people, you already have 3 boys in the other group. So you don't have to do. So you go AC5, and that's it. Or you can go AC5, select 5 people from A, and then select 3 people from the remaining 3. And now you know y is equal to 1, isn't it? Because there's only one way of selecting 3 people from 3. So now you see NCN is 1, because there's only one way of selecting everyone, one way of selecting no one, right? That makes even more sense when we look at the binomial coefficient. Okay, so the answer will be AC556. The answer's there. I think it's right. Okay. How about the next one, 53? What would you do? How many ways first and second and third prize be awarded in a class of 15 students? All right, who can give me the answer? 53? All right, anyone can tell me. Megan? Did you do it? 53? Yep. Yeah, because or you can just go like this, that's a good way, or you can just go 15P3 because the order are important. Okay, good. Next one. In how many ways can 3 students be selected from a class of 15 to participate in a debating competition? What would the answer for this going to be? So in that case, doesn't matter which order, isn't it? So what would you do? You would do 15C3. You see the difference when the order is important and when the order is not important? You get C. Okay, good. I think we know how it works. C and P are different. Okay, we'll do some question with restrictions. And how long have I been talking? Okay, so we may stop the video soon. And then we'll just do a couple more questions. Combination with restrictions. Let's look at 55. Yeah, let's look at this one. 55, have a read. I want you to have a try and see if you can work out. Yep. All right. Okay, good. All right, let's start. Who can give me the answers? The first one. Let me ask the student. Jessica, part A. Exactly 2 women in the committee. Yes, that's right, because you select exactly 2 women and then 3 men. Okay, 3 men, 2 women. Okay, good. So you should get the right. Oh, there's no answer. So let's work out. 62 C2 times 9C3. All right, should get 1260. Any question? Okay, someone else can tell me at least 2 women. What would that mean? What it means could be 2 women or more. So what would you do? So you go 62, 2 women or 3 women. So 2 men or 4 women and 1 man or 5 women. Maximum because you only select 5 people. Oops, sorry. Okay, like that. And you just work out. And you should get 2, 1, 2, 1. Anyone did it differently and want to share? And when you see the word at least, sometimes it's better to do the complement. You do the total minus 1 woman or no women. Because that should be 0. Sorry, 9C0. Sorry. Select no man. Okay, 1 woman or 0 women. Let's see if we get the same answer. So we get the total number of ways will be 15C5 minus 1 woman will be 6C1, 4 men, and then 6C0, 5 men. See if we get the same. So it's just slightly shorter, okay? So when you see the word at least, maybe it's quicker to do the opposite. So it's 15C5 minus 6 times 9C4 minus 9C5 because 6C0 is 1. Okay, what do you get? We get 2, 1, 2, 1. Okay? So you get the same way. So note this way. So this is method 2. Method 2. All right, any question? And then we're going to move on to, do another one. Do this page. Okay, how about the next question, 56? Have a try, have a think. Okay, anyone want to contribute? A and B are both selected. So you're going to select 6 from 10, but A and B must be included from the 6. So I'll ask you in 1 minute. All right. So who got it? Okay, Mitchell, you have to explain. What do you do?
A and B are already.
Yep.
Take them away.
Yep. So you got 8 people left, and then you're going to select how many?
4 spots left.
4 spots left. Yeah, because A and B are automatically selected. Okay, good. Because you got 4 people left to select from the 8. Okay, good. The next one's a little bit more tricky. It's the same question, but it says you must exclude A if B is included. Okay? I'll give you a clue. You have to do cases. There are 2 cases. Think about it. Give you a minute. We'll go through. Okay, all right. So who want to contribute? So who did it? Elle, did you do it? Okay, all right. What did you do? All right, so 10C6 is the total ways minus, say again, minus what? Minus the way, how many ways A and B are together. Oh, very good. Okay, I didn't think of that. So you just do complementary. Wasn't that tricky I thought. Okay, good. So it's 140. Yeah, you just do complementary because A and B cannot be included together. All right. Okay, didn't think of that way. That's a good way. Good. Excellent. All right, let's move on. All right, how about the next page? Let's do the next page. We're not going to do 58. We'll just do 59. Have a try 59. All right, try 59. Give you a moment to think about. It's pretty easy. Again, this one you do a lot of. So you say 3 liberal. Let's start with 3 liberal. 1 independent. So you got, if it's 3 liberal, that will be 3 labor. Or you could have 4 liberal, 2 labor. Or you could have 5 liberal, 1 labor. But you can't have less than 1 labor. So you have just 3 cases. So for what do? We select 10, how many independent? 5C1 times by 8C3. Let's put 85 there. And the labor is 8 labor, 10 liberal. So it's 10C3. Alright, so you go 10C3. 10C3 multiplied by 8C3 plus 5C1 times 10C4 plus times 8C2 plus 5C1 times 10C5 times 8C1 and add them up together. Okay? That should give you this. And try the next one, at least 1 independent. Again, you just have to extend the table with 2 independent or more independent. Okay? See if you can finish it off. And then we'll do the last page, 25, then we should be ready. Oops, sorry. Oops. Okay, good. All right, so you could have 2 independent. In that case, 3 liberal, but 2 labor. Or 4 liberal, 1 labor, and it stops there because you can't have less than 1 labor. Or you can have 3 independent, 3 liberal, and 1 labor. In that case, that's the last case. So what you do is the total number of ways will be the answer from the previous part, which is 73,080 plus these 2, which is 5C2 times 10C3 times 8C2 plus 5C2 times 10C4 times 8C1 plus 5C3 times 10C3 times 8C1. And you should get this thing. Anyone see a different way? Well, when you see the word at least, what do? You think about the complementary. So what's the So at least one independent means the total minus no independent. And that's going to make things much easier because total ways is you just select anyone. So how many people altogether? 10 liberal, 8 labor, 5 independent. That's 23 people. 23 to C7 minus no independent. And how many independent? 5. So there's 18. Oh, but then there's a problem. At least one liberal, at least 3. Oh, so you can't do the opposite. Sorry, so you have to do it this way. Because there's a restriction on the labor and the... Actually, can you still do that? No, you can't. It's too hard. I don't think it works. Because you need to have at least 3 labor, 1 liberal. At least 3 liberal, 1 labor. Okay, it doesn't work. So there's no second way. All right, good. Let's move on. One more page, then we're done. This is the last one. Okay. How many 4 letters are chosen from the word assumed? Find the number of 4 different 4-letter selections that can be made containing no S. So when they say selections, you only select A, U, M, E, D. 5C4. No problem. 5C4 is 5. 4-letter selections that can be made containing one S. So in that case, you just have A, S, U, M, E, D. You go 6C4, which is 10. Right? 4-letter selection containing, you say containing one S, does not 64, sorry, because S is already selected, S is selected already, you only have to select 3 letters from 5. Does that make sense? Because one S included, only need to select 3 letters. Get the idea? What if you have contained both S's? So that means 2S is selected. You have to select 2 letters, right? Because 2S is already selected. So 2S selected. So therefore, only select 2. Okay? 2 other ones. And the next one gets a bit harder. Arrangement containing no S. So what do you do? A, U, M, E, D, there's 5. So what do? You go 5, P4. Does that make sense? You're going to arrange 4 letters from the 5. Okay, assume. Okay, next one, arrangement containing one S. This one gets a bit harder. One S is already selected. And then you have to arrange the letters. So what you do is this. You're going to select 3 letters from A, U, M, E, D, right? So which is 5C3. After that, you select the 3, including the 1S. There are 4 letters to arrange. Arrange 4 letters. So what do? You multiply the selection by the arrangement. Does that make sense? You select the 3. After you select that, they can be in any order. So let's order them in 4 factorial ways. Let's see if it works. So that's 10. Yeah, it should be work 120. 240. All right, see if you could try the next one. What if it has 2 S's? That gets tricky, and there will be repetitions. Think about what to do. So that means how many letters do you have to select? Instead of selecting 3, you select 2 letters, right? So you select 2 letters because 2S is already selected from A, U, M, E, D. So you get 5C2. And now there's 4 letters to arrange. But what else you have to do? Remember there are 2 S's. What else you have to do? divide by 2 factorial because there are 2 repetitions. Okay, so let's see if it works. Yeah, it should work. Divide by 2, you get 2 for 120. Okay, and what's the last bit? Arrangement that can be made containing, I think that's the last one. Oh, finished. Okay, good. Alright, so we'll continue with this booklet next lesson. In the meantime, can you continue with this worksheet, permutation, combination? Try them. Yeah, very good. Have a try. Or you can do the chapter review if you have time. Alright, finish.